applications of the photodiodes mean alarm system, count items on a conveyor belt, the photoconductors, compact displays, smoke detectors, medical applications such as detectors for computer, tomography, etc. So these are all the applications of the photodiode. Next thing is third one, solar cell. Solar cell is also known as photovoltaic cell. 7th lesson it converts the light energy into electrical energy. That electrical potential difference is produced in the form of photovoltaic effect. That's called photovoltaic cell. We have 7th lesson. So the same thing here. So here the P and the N type semiconductor materials are used here. The combination of P type and N type materials are used together. So see that P type and N type. P type semiconductor is a positive and N is a negative. Then the polymer back, that black electrical contact is there. An anti-reflecting coating is coated on the above the N-type material because it can absorb all the light energy. It won't allow the light to reflect from the surface. So it can convert that all the light energy into a electrical energy. That's why that anti-reflecting coating is used on the top of the glass that is used for the protect the system. So front electrical contacts, everything is on the screen. So this is solar cell, and how it is constructed here. So when light energy falls on the that for solar cell, what happens? That energy here light is also a form of energy. Energy is absorbed by the charge carriers, so it can penetrate through the depletion layer. So the movement of charge carriers are producing the current. That current is taken out through the load resistance here, that is box. So that light energy is absorbed by the charge carriers. That electrons can flow from the N-type silicon to the P-type. So the flow of current, that potential difference is produced here. Due to the potential difference, the current is flowing from the positive terminal to negative terminal. So we can take out that current through the load. So this is the principle behind the solar cell. So solar cell used to convert the light energy into electrical energy. So that cells are connected in series or parallel, we can produce the very large amount of energy. So all the cells can be connected through series connection or the parallel connection. So combining all the cells are in a series connection, we can produce a large amount of energy by using the solar light. So what are the applications of solar cells? These solar cells are widely used in the calculators, watches, toys, portable power supplies, etc. These are all the things that are first point of that application. Second one is solar cells are used in the satellite and space applications. Space electricity produced பண்றதுக்கு நம்ம solar panels use பண்றோம். Next thing is solar panels are used to generate electricity. So electricity purpose. So these are all the applications of solar things. So next thing is we are going to see that the bipolar junction transistors. Bipolar junction transistors. So bipole, that is two poles are there. Bipolar junction. So two junctions are there. So that's why this is called bipolar junction transistor. You know that in 1951 William Squarky invented the modern version of transistor. So that is a very big invention. That is using that only we are simplify all the electronic devices in a very simple. Okay. So the heat loss in a transistor is very less. That's why it is foundation of integrated chips contain thousands of miniature transistors. That's called integrated circuits. Then it will become a microprocessor. So nowadays we are using the microprocessor. In bipolar junction transistor, this consists of the silicon and germanium. That crystals are used in the bipolar junction transistor. We know the two type of materials, P-type semiconductor material and N-type semiconductor material. So the two P-type material or one N-type material or two N-type material or one P-type material. So using that we can produce the two type of bipolar junction transistors. See, diode means P and N type is there. P type, N type. ரெண்டு join பண்ணோம் அப்படின்னா கிடைக்கிறது நமக்கு PN junction diode. இங்க ரெண்டு N type ஒரு P type or one P type two N type யூஸ் பண்ணி என்ன பண்றோம் அப்படின்னா bipolar. பைனா ரெண்டு போல் இருக்கு, ரெண்டு junction இருக்கு. So see here you can see that image. Here N and P is one junction. That's called emitter base junction. So here you can see that this is collector base junction. So this has the three parts. One is called emitter. The center thing is called base and is called collector. So This is the circuit symbol. So in circuit symbol, that where we have to indicate that arrow mark whether it is a NPN transistor or PNP transistor. NPN transistor means that arrow mark shows in the outward direction, or PNP transistor means arrow mark shows in the inward direction. So this is called emitter, base, collector. That is indicated in the circuit form here. So this is a symbol of transistor. This is for NPN transistor and this is for PNP transistor. See here two junctions are there. This junction, emitter base junction. This is called base collector base junction. So here the first one is emitter. What is mean by emitter? Emitter means it is the main part of the transistor. That emitter, it contains large number of impurities. That means it is heavily doped. It contains large number of electrons, that is charge carriers. Next thing is junction, that is base. Base is also a lightly doped, but it is a very thin layer. The thickness is only up to 10 to the power of minus meter. Only very thin layer contains very small number of charge carriers. But collector, it is very big in size, in physical size, but it is lightly doped, so it has only very small number of charge carriers, but it has the large amount of space. Okay, that's called a collector. So these three things are not equal because emitter is heavily doped, that is lightly doped, and base is very thin layer. So these are two type of transistor. So transistor biasing. Next thing is transistor biasing. Biasing means you know that we are going to apply the energy. So apply how we are going to give the energy to the transistor. So it has the three modes of transistor biasing. One is forward biasing. Forward biasing means that emitter and base is connected in a forward bias. So it is negative N. N-type material is connected to negative. It is P-type. P-type is connected to positive. So it is forward bias. See here, N-type is connected to positive. P-type base is connected to negative. So it is a reverse bias. So it's called forward bias and reverse bias. In forward active means always that emitter and base in a forward bias condition, collector and base in a reverse bias condition. Saturation. Saturation means emitter base junction and collector base junction, and both the junctions are in a forward bias. The transistor has very large flow of current. So ரெண்டுமே வந்து forward biasல இருந்தது அப்படின்னா அதிகமான current flow ஆகும். So அப்ப என்ன ஆகும் அப்படின்னா in this mode transistor is used as a closed switch. So it is used as a closed switch. It's a closed switch. So current is flowing very high. So it is used as a closed switch. That means there is no current is flowing through the one device to that is from transistor to any other device. There is no current is flowing. So closed switch. Cutoff. Cutoff means in this base is emitter base junction and base emitter junctions. Both the junctions are in reverse bias condition. ரெண்டுமே ரிவர்ஸ்ல இருந்துச்சுன்னா then the mode is called open switch. ரெண்டுமே ரிவர்ஸ்ல இருந்தா open, ரெண்டுமே ஃபார்வர்ட்ல இருந்தா closed, or ஒன்னு ஃபார்வர்ட்ல இருந்து இன்னொன்னு ரிவர்ஸ்ல இருந்தா that is forward active. So this is all the three biasing of transistors. Now transistor configuration. Then how we can configure the transistor? So this is a NPN transistor. So NPN, you know that. So NPN, see NPN is here. So in forward bias condition, forward active means the negative is connected to N type, P is connected to positive terminal, and reverse bias condition, that collector is connected to positive, the P type connected to negative, so reverse bias condition. So this is NPN transistor. So it is a symbol, it is a circuit symbol. Okay, circuit symbol is this one. Next one is this is transistor, and in this configuration this is called CB mode. CB mode means common base mode. என்ன சொல்லணும்? Common base mode. Common base. You know that this is emitter and center thing is base and this is collector. Base is center. This is the base junction. So common base mode means base is common between the emitter and the collector. It is center. So this type of mode is called common base mode configuration. So base is between the emitter and the collector. Okay, so this is input and the output. So this is called CB mode. Next thing is, see here, CE mode. E means emitter. C means common emitter mode. See here, emitter is here, collector is here, and base is here. So here emitter is between the input and the output. So this is called common emitter mode. So this is the circuit symbol for common emitter. So emitter, arrow mark indicating in the outside direction. So this is NPN transistor. So from the arrow mark we can identify that this is NPN transistor. This is called common emitter mode. So this is the second type. And third type, common collector configuration, CC mode. Common collector, see, this is a collector. Collector is between the input and output. So this is called common collector mode. So IE is the emitter current, IB is the base current, IC is the collector current. Okay, so this is called common collector mode. So you can measure the output current here and input current here. So all the three modes. Next thing you can see the animation. So common base configuration. So it's a transistor. So PNP transistor. This is also PNP transistor. Centered in that forward bias condition. So it's a symbol of transistor. So it's connected to the battery, forward bias and reverse bias for the collector base, forward bias for emitter base. So this is for common base configuration for PNP and NPN. See the direction. NPN and PNP is in opposite direction. So common base configuration. So common base means base is between the emitter and the collector. So the battery is connected. See here, it's a characteristics of transistor. So transistor characteristics. The input characteristics, output characteristics. You can see that visually. I will explain you in the graph. So input characteristics means output kept constant, and only you have to vary the input values. So voltmeter and ammeter is here. So ammeter shows the current, that is IP, that is base current, that is input current. The corresponding input voltage. See, input voltage, input current is noted. This is constant. This is for 5 volt. We are placing the PCB. See that 5 volt. We are going to place the 5 volt common base. You will get the graph like this. The current is gradually increases. For the PCB is 5 volt. You are going to do in a practical. So input resistance. That how you are calculating that input resistance for Zener diode. The same method you can calculate the input resistance for the transistor also. So here VCP means a constant value of VCP, that the voltage is changing in emitter base, that's equal to the flow of current in emitter. So you get the line like this. So connecting the two values. So that is the VCP for result. This for 10 volt. See, whatever may be the VCP is 5 volt or 10 volt. The breakdown region, the line is in a straight. So your PN semiconductor at a particular voltage which allows a large amount of current. So that transistor. So N type, P type, and N type is here. So P type and N type is here. The depletion layer is very high because only it is lightly doped between the base and the collector. But here N and P type it is very less because this heavily doped charge carriers are very high. But P is a very thin layer. It contains very only small amount of charge carriers. So we will get the graph like this. So now we are going to study the output characteristics. Output characteristics means we kept input is a constant. We are going to vary the output characteristics. So that means we are going to study the IC. See here, it is a cutoff region. It's called the cutoff region. This is called the active region. So we are going to calculate it in the graph by using the in practical also. So you are going to do that things in your theory. The transistor, yes. You are not understand. I will explain everything again by using our book diagram. Okay, just to see the animation how we are measuring the input characteristics, output characteristics, and current gain. So this is the first one. It's called cutoff region. So yeah, below that line, that a transistor does not work in this region. This is called saturation region. That current does not flow more than this region. It's called saturation region. Called cutoff region. So we'll get the graph like this. From that we can calculate that the output resistance. So we can call slope here and the AD region. We can calculate the output resistance. So output resistance R0 equal to voltage across common base and flow of current in collector current when at constant emitter current. IC is almost independent of CT, that is collector current is independent of base collector current. You can play this video 2 to 3 times. Definitely you will understand after I will teach. So output charges we are studying that. So input is kept constant. So input voltage and input current is measured by using the voltmeter and the ammeter. So suppose large current is flowing through the transistor to destroy the transistor. So what are the transistor parameters? The transistor parameters are input impedance, output impedance, forward current gain, and reverse voltage gain. Input impedance delta V, that is base emitter is 5. IE, that is emitter current. When at collector base voltage is constant. So get the graph like this. So output again is called current gate. Output current IC is the collector current. IE is the input current. Output current by input current, you will get the order current gain where common phase voltage is constant. So it's the common base configuration. Our sum is